Hello everyone, welcome to this video lecture on IPv6 routing protocols. So the routing protocols or the dynamic routing protocols can be categorized into two groups. First, the intra-domain routing protocol and the inter-domain routing. About the intra-domain routing protocol, which means it supports the routing or it manages the routing that happens within an autonomous system. Example protocols are RIP, OSPF, ISIS. And about the inter-domain routing protocol, it helps in the routing between different autonomous systems. So that is the inter-domain routing protocol. An example protocol is the BGP protocol. These protocols supports IPv4 addresses, whereas now for IPv6 addressing, we need some extension features in those protocols to support the bigger size of the IPv6 address. So that's why we are now going to learn about the IPv6 routing protocols. First, about the RIP-NG. So RIP-NG is an extension of the RIP protocol. It is exclusively designed for the IPv6 addressing, but the basic features remains the same. It uses the hop count as the metric to find the best path to reach the destination, and then it uses the periodic update for every 30 seconds. And the RIP-NG messages makes use of 521 UDP port number and the multicut address of FF02::9. What about the configuration of RIP-NG? So you have to include two important lines in the global configuration mode, which is the first one is IPv6 router space RIP. So this is being used to differentiate between the multiple RIP processes. And the second line which should be included is IPv6 RIP enable. So this has to match the one which is used in the previous stack command. So these are the two important things needed for the configuration. Yes, as the picture, this slide tells, it is an interior gateway protocol or intra-domain routing protocol. It helps in the routing happens between within an autonomous system, and it helps the neighbors to compute the routing table by exchanging the information between them. And just now only we saw that the periodic update is every 30 seconds. And RIP-NG is disabled by default. We have to enable with the help of the two enable statements we have seen in the previous slides. And the same concept, this RIP-NG also makes use of Bellman-4 distance vector algorithm to find the best path to reach the destination. And it allows the host and the routers to exchange information for computing the routes through an IP-based network. This is also again one of the basic ideology which works well in the RIP protocol also. And this is particularly utilized for the moderately sized autonomous systems. The RIP-NG application is moderately sized autonomous system. So the Bellman-4 distance vector algorithm is utilized to frame the routing table in case of RIP-NG protocol. Moving on to the RIP-NG packets. Yes, the packet header contains these many fields: command, version number, destination prefix, prefix length, metric, and root tag. First, about the command. The command tells whether the packet is a request packet or a response packet. So request messages, they seek information for the router's routing table, whereas response messages or can be of two types. One is periodically for every 30 seconds. Otherwise, based on any request also, it can be sent. So it can be either reactive or proactive. And the periodic response messages are called as the update messages. And this particular update messages contain the command, version fields, and the destinations and other metrics. The next field is the version number. So this specifies the version of the RIP-ng. So this will be version 1. And then